we're starting. This is a follow-up on that one lab that you guys did last week where you had to reflect that little pulse and then you added some of them. Well, this is no different from that. The only exception is you have a bunch of weird, irregular looking waves so that you can practice applying the rules to add waves and reflect waves. Okay, so don't be afraid of this word. This just tells you to combine the wave. Okay, so this is just a little bit tedious, and actually the fastest way to do this would be to label all the columns like this, 1 through 3. Okay, trust me on this one, if you label the columns, it will be a lot easier. In the middle is where you are going to add the two waves together. Okay, so let's just go to the first column and add those together. If it's just a flat line on the dotted line, I would call it a 0. So they're both zeros. So 0 plus 0 is going to be 0, and that's just going to be a flat line. Okay. Now go to the second column. On the left, it's a 0. On the right, it's a +1. You see it? So 0 plus 1 is going to be +1 when they combine. And you just do that until you're done with the whole wave. So this is +1 on 3, -1 on the other third column. And that makes 0. So you go back down to 0, which is on the dotted line. Okay, so you'll get fast in a bit, but try to be careful. Okay, so this is +2, and this is +2. Right, so together is going to be +4. Okay. Also notice that column 3 is an example of destructive interference, and column 4 is an example of constructive interference. All right. See, because I have things labeled, I don't get lost when doing these problems. Okay, now I'm at column 5. This is a -1. This is a +1. Again, that goes back to 0 when you add them together. That's another destructive interference. 6 is -1 and +3. Okay, so this isn't really a destructive interference or a perfectly constructive interference. It's just interference, resulting in a +2. 7 is +1 and -3. So that's going to result in a -2 all the way down here. -1 for 8, -2. So that goes down to -3. +2 on 9 and -2. It takes you back to 0. And the rest of that is just 0, right? On both sides. So there you have it. That's what the waves would look like when combined for that moment. You know, that moment when they're superimposed on top of each other. Another question might be, what happens after they superimpose? Do they bounce off each other? Do they stay there? Or do they just continue to go past each other? And hopefully you just answered they just go past each other. Okay. If you're in a movie theater, imagine all the sound speakers coming out, and the waves are always doing something to each other, but they kind of go past each other after they're done. interfering. Okay, so B and C are just extra practice for you guys. Just take your time, make sure you're comfortable. The only questions I really have about these are, how do you do these halves? Well, you know, just treat them as a positive 1/2 here, over here, you know, negative 1/2, and they would cancel. Okay, so try to turn them into numbers if it doesn't make sense to you. Okay, so that's waves combining on top of each other. Number 2 is about wave reflection. And the thing to pay attention to here is whether you're reflecting off of a free end or a fixed end. Pay attention to the direction of the wave travel. So the wave is going to the right when it reflects off of an end. Make sure that you know that the wave is now going to the left. Okay, what does it look like while it's traveling to the left? What does it look like after it's been reflected? And in this case, off of a free end is free to move, which means the wave does not have to invert. So it is just going to turn around without doing a backflip. Okay, so what does that look like? Notice that this is the head of the wave, right? That's what you call the wave front. And so you need to start with that, but on the left side. And then just backtrack. Okay, there's that part. And then here, there's no inversion, so you just go up, over, and I'm actually not very good at this. I would rather be doing calculus or something. But you know, if you pay attention, this could be pretty easy for you. Okay. And just step back a little bit. Make sure that it makes sense to you. Okay, so this is a wave. It was going to the right. Now it has been reflected and is going to the left. Okay, I don't bother with labeling the columns in this one. Okay, the fixed in one is the one that's a little bit harder, because this is tied down, or you know, you hit a solid wall or something like that, and the particles are not free to move about, which means to turn around they also have to do a backflip, right, an inversion. Okay, so make sure you understand that the wave is now going to the left. Okay, and then start with the head of the wave, and then this time instead of going up, we're going to go down. Okay, if the wave doesn't do a backflip, it can't turn around. So in order to do the backflip, it has to turn around. Not enough, did I? Okay, I need to go up one more. What happened?
Wait, why did you go up another one?
Because there's... I only went up 2 when I was supposed to go up 3. What am I doing? Am I doing this correctly?
No, you're supposed to go up 1. You're supposed to go up 1, not 2.
Okay, so we're here, right? Yeah. So maybe you should label your columns. See, I told you I was not very good at this. So if you realize you made a mistake, well, make sure you use a pencil. Okay, where do we go from here? Do we go up or down?
Down.
Down? How many? 3. Okay, and then what do we do from here? Just a diagonal to the dotted line, and then a straight line. Okay, just step back a little bit to see if the wave has been reflected and inverted, right? So the way I remember a fixed end in reflection is this right here. I have to flip it once horizontally, and I have to flip it again vertically, right? I have to do it twice. And that's it. That's it.